command that we added in Postgres 10. It's called create publication. And a publication is basically a way of advertising the availability of a logical replica. Over on the standby, I connect to the same to the standby server, and I create the same table that I created over here on the primary. And down here again, a new command, I say create subscription, and I specify the port number of the primary. So this port number here is the same as that port number there, right? That kind of makes sense. So there's that port number, there's that port number, okay? And I give the name of the publication as my pub, which happens to be the same name as over there. Okay, so why does that work? Okay, so what happens if I now look at my table, you'll see that the row I inserted in the previous slide, the 1, already exists here, okay? And if I insert a 2 into the primary, it automatically gets copied into the standby, okay? And that's really what the replication, every time I add a row, it gets copied. Every time I delete a row, it gets removed. And every time I update a row, it gets updated. So this is something, once you set up a subscriber and a publisher, the two tables remain synchronized. And of course, if one of them was to fail, the other table has all of your data, and that's very, very useful. So why would you want to use logical replication if you already have a physical replication and the ability to copy a whole server? Why would you want this? Well, of course, logical replication gives you what we call table-level granularity, meaning we're not copying everything, we're just copying one table or multiple tables. One advantage to this is that you can have multiple tables from different servers all copied onto a single server. So imagine you have different offices and you want to run reports on one server. You can have all the offices replicate their data into one large server, and then you can run all your reports on that server and know that the data is current, because every time somebody changes something in an office, it gets updated automatically. The second option is that you can broadcast, meaning that you can have a single table that gets copied to multiple tables. So you might have a product list and a list of products, and every time you add a product to the one machine, all of a sudden all of your other computers get a new copy of that new product automatically. Okay, so that allows you to have granular replication, either many tables to one table or one table to multiple servers. It makes major version upgrades easier, and also you can create special tables and indexes on one machine without having to have them on another, because you can do different things on the different computers. So that's why that feature is really useful. The second feature that I think is really important in Postgres 10 is something called partitioning. You may not be familiar with that, but partitioning allows you to have a very large table split up into pieces. So instead of having one really, really big table, you're now breaking it down to smaller ones. And the advantage of having smaller ones is that you can remove tables pieces of the table you don't need anymore. You can drop old data, for example, if they're in old partitions. You can put some data that's very commonly accessed on SSD, and you can put archive data, for example, on magnetic disk or on a network attached storage. So you have the ability with partitioning to take a big table and break it into pieces and manage those pieces independently. One of the most common uses for table partitioning is for time series data. So for example, if you're storing all of your sales for every month, for example, often you will have a new table for every month, and you may keep all of your sales data for 2 years, and when 2 years is over, when the data is over 2 years old, you just drop the old sales table. You drop the month that's over 2 years old. So this gives you a very easy way of managing large amounts of data and also removing old data that you don't need anymore. Instead of having to go and find all the old data in one big table, you put all the data organized by date, and then you can just delete the data, delete the table that you don't want anymore. Postgres has had the ability to do partitioning for several years, but it was very awkward to set up. You had to set up an inheritance table, a parent, and then a child tables. You had to create triggers to route the rows into the right table. You had to add check constraints. So it was a very awkward system. Fortunately, in Postgres 10, we now have a syntax here. Here's an example of a table called numbers, which we're creating right here. And we're specifying it's partitioned on a column called X. And then I can create a child table called negatives, which represent the negative values, and one called positives, which represent the positive values. This is a very silly example, but you get the idea. So if I look at the numbers table here, it tells me that I have a positives and a negative children here in red. And if I look at the negative table, it tells me it's from infinity to 0, and the positive is from 0 to positive infinity. So basically from the beginning of numbers to 0, and then 0 all the way up. How does this actually work? Well, if I insert both positive and negative numbers into the numbers table, you'll notice that all of the negatives have gone into the negatives table automatically, and all the positives have gone to the positives table, even though if I ask for numbers in the numbers table, the numbers appear proper. So the numbers appear to be correct. They appear to all be in the numbers table, but in fact, they are physically in the negatives table and the positives table. Now, of course, this is a very silly example, but you get the idea of how you would set this up. Okay. So in Postgres 10, we have the ability to properly create child constraints and to automatically route the rows into the proper partitions. Yes?
May I ask you about the number table?
Yes.
What will be with 0?
Yes, okay, so I mentioned that in my last talk, and I skipped it this time. In this particular case, I'm cheating, and I'm assuming that 0 is a positive number, okay? I did mention this when I was in Rostov-on-Don. I said, hey, 0 really shouldn't be in either one. We could have created a separate table for 0, but that would be kind of odd. One of the interesting parts I did not mention is that when you specify a range here, this value is inclusive. And the second number is what we call exclusive. So it does not include, it includes up to that number, but not that number, okay? And effectively, so this 0 is not included in this negatives table because it starts inclusive. The 0 is included in the positives table. We did have a long discussion about the fact that the first number is inclusive and the second number is exclusive. You would think that was kind of a silly discussion, but for integers, it's kind of clear. But when you start to deal with dates, dates become very hard, because if the last number was inclusive, you'd have to kind of say from midnight of one day to 23:59:99, and then you'd have this nines, which would effectively just continue, right? Because you couldn't put enough nines to be sure you got all of the numbers. So we had a long discussion about this. Again, integers are easy, but when you start to talk about a floating point number or a timestamp, doing exclusive on both sides would have been very hard. So we decided for inclusive on the beginning and exclusive on the end. And that was probably the simplest syntax we could come up with. Yep. But you got me. You're absolutely right. Other questions? Yes, sir. That's a great question. In fact, let me. The answer is actually in this slide. So I'm going to do this slide to answer your question. So, in Postgres 10, the syntax is very accurately described. It's mostly syntax sugar. So it's creating when you create the parent and the children using the syntax. It's creating the parent table and the child tables. It's also adding check constraints to match, and it's adding a routing, so when you insert, it knows which child table to put the row into, right, which partition. Frankly, that's not very useful. It improves administration of Postgres, so people who are having to create these partitions manually now have a better way of creating the partitions. It's less work. Okay, but frankly, in terms of really using the full value of partitions, that's not going to come until the next release. Okay, and I'll be talking. I actually have a slide later about this because effectively the syntax itself is useful, but the syntax. Once you have the syntax, it allows you to optimize partitioning in a much more powerful way. And unfortunately, we did not get that done in 10. Fortunately, we will have that in 11. So what we basically want to do, for example, is if somebody inserts a value and there's no child for it, we should be able to create a child partition to match the new value instead of throwing an error. If somebody updates a row, we should be able to move it from the old partition to the new partition, right? We should be able to scan the partitions quicker. So if you have 1,000 partitions, very possible, okay? If you're using a partition a day, in 3 years, you're gonna have 1,000 partitions. So if we have to scan all the partitions, this partitioning syntax should allow us to scan through those partitions much quicker than the old method. This one right here is a little hard to understand, but right now, when we prune or we identify the proper partition, it's done at the optimizer level. For those of you not familiar, there's 3 stages to a query. There's the parser, the optimizer, and the executor. Right now, we can only perform the filtering of child tables in the optimizer, which pretty much requires that you give Postgres a constant value and that you not use prepared statements, which is another problem, okay? What we are hoping to do in Postgres 11 or 12 is basically allow you to do partition pruning in the executor. And what that would mean is something like a join would properly filter partitions, or prepared statements would properly filter partitions. And also at the bottom, the idea of processing partitions in parallel. Again, another really nice feature. So frankly, the features in Postgres 10, I think, really just benefit administrators. But if I look at Postgres 11 and 12, you're going to start to see partitions allowing for much more efficient use of very large tables. And that's why it's a multi-year process. We just couldn't do it in 1 year. Yeah.
Can we insert something in the subtables or update subtables?
You can. So the question is, I'm sorry, I should be repeating the question. The previous question was, is this just syntactic sugar? That was the question, I'm sorry. The question now is, I'm sorry, can you say that again? Right, so the question is, can you insert values directly into the child tables? And the answer is yes. So for performance reasons, you might want to insert them right into the children. The rows that you insert are going to have to match the requirements you put on the table. So I couldn't put positive numbers in the negatives table or vice versa. But yes, you can bypass the parent and put them right into the children. Yes. Other questions? Great. Oh, yes, sir. So can you have the same number in two children? The answer is no, I don't think so. Hold on, let me think about that. No, because the system would not know which table to route the rows into. You could create, if you created the partitions manually without this syntax, you could do it. I don't recommend it, but you could do it. But if you use the syntax, the ranges cannot overlap in the tables. Yes. Yeah.
Does the partitioning works as it was in previous version based on triggers?
So does the partitioning operate in the same way based on triggers? Partially. So in the old system, you would have to write a trigger in PLPGSQL, and then you'd have to update that trigger every time you added or removed tables. That was the big maintenance problem. In this new system, we are calling sort of a trigger, but it's a system trigger, and it's written in C, and it's part of the server. So it's not really a trigger. It's an internal function that we're calling, as we would call any function in the back end, to allow us to identify which table the row gets into. So this is going to be much faster at routing rows into the child tables. Yeah, no question. Yes?
And what about sharing? Can we move the child table to another server and create a link to it? How we should do this?
So the question is, what about sharding? Can we move a child table to another server? This gentleman is way ahead of me here. He's asked another question that fortunately I have a later slide on, but then that's good, okay? Yes, this feature allows you to have a table that is not local to the machine. And effectively, this would allow us to have a much, much larger set of tables, because now our tables can exist on other machines, perhaps dozens of machines. And that is actually number 10 on my list of things for Postgres 10, is that we are continuing to improve partitioning, which will allow us to do very sophisticated sharding solutions, as you've already suspected. In fact, this feature was needed for normal servers, but I think the real reason we developed it now is because we're working on sharding. And this is going to make sharding much easier, because now all you have to do is create the child table somewhere else as a foreign data wrapper, and the system will automatically route the inserts and updates, deletes, and the selects to that child server now, okay, the shard server, which makes for very, very large databases possible. Yeah, as you may have known, I've been talking about this for a couple years, and it looks like we finally got some very good results. I do have a slide, number 10, which kind of illustrates some of the other things we're doing for sharding, but I think we're very close. It's a great question. Thank you. Other questions? Very good. Number 3, this is a somewhat embarrassing item for me. We've had hash indexes since I started with Postgres, and frankly, since the time that Postgres was developed at the University of California at Berkeley in the mid-'80s. But unfortunately, hash indexes, up until this release, were not crash safe. I don't know why. nobody ever got to it, or for whatever reason, they had not been crash safe. So in Postgres 10, hash indexes are now crash safe. Hash indexes are now replicated. We've improved some of the bucket splits for as hash indexes grow. We've improved lookup speed. We've improved index growth and cleanup. So I really feel that now hash indexes are no longer an embarrassment to me. We can actually use them safely. I will add that in Postgres 9.5 or 9.6, I finally got a warning. Every time you create a hash index, it would issue a warning that this index was not crash safe and could not be replicated. And it seemed like the warning finally got somebody to work on it. So I'll consider that a win, because for years we had it and nobody was complaining. But I guess that error, that warning every time somebody created it was enough to get somebody to fix it. Another sort of odd item, I think, is how Postgres does collation, localization. Postgres has always used the operating system library, typically glibc in Linux. On Windows, it uses the native Windows collation. But there have been a number of cases where operating system upgrades have changed the collation of the operating system. And when the collation changes in the operating system, Postgres does not know that. And Postgres has indexes which rely on the old collation. So imagine you have a certain ordering of letters for an older version of the operating system. You upgrade the operating system, but the indexes remain intact. And now all of a sudden, the Postgres can't find some of the rows because the ordering has changed. And from what is it, the index has the index stored on disk has the old ordering, and now we're using a new ordering as we call the operating system. So we have added a new ability to use a library called ICU. ICU has versioning, and therefore we can detect when collations change and inform administrators that they need to re-index. So again, nice, sort of an odd item, but pretty important, I think, for Postgres. Number 5, this is one that many people are very excited about. I'm not sure I understand, but I guess I don't do enough of this. Effectively, Postgres has a capability called Synchronous Commit. And in Synchronous Commit, when you make a change on the primary, it will automatically synchronize and force the data to the standby, and it will wait for the data to be acknowledged before it'll acknowledge the commit. So this is a case where you're kind of saying, I'm going to commit this transaction. We send it to the standby. We wait for the standby to process it, and when we get an acknowledgement, then we commit on our local machine. Many people have multiple standby servers in the organization, and prior to Postgres 10, if you wanted to synchronize to multiple servers, it would only really do the first one you listed, or if the first one went away, the second one you listed. The new capability now is called Any, and it allows you to synchronize to any of the servers in your list, any one, any two, and so forth. This is very important if you have a large server farm and you've got a lot of standby machines and you just want to synchronize to one of them. You don't want to wait. The problem before is if the first machine in the list was very busy, it might take a long time to acknowledge. Now you can basically ask all of them, and whichever one answers first, you can continue. So this would basically allow you to do much faster synchronization. It's called quorum commit. For some reason, it was very hard to develop, but a lot of people find it really useful. Number 6, this is an item that actually, any questions? Yes? Okay, so the question is, what happens if all of the standbys die? Believe it or not, Postgres will not continue. So it will basically stop committing. That's a good question. So the question is, can you like time out or something? And we have talked about adding a timeout to this, but we don't have it. And I think it would be a nice feature to have some type of timeout that says, if I can't synchronously commit, stop trying, right? And also alert someone because something's terrible has happened. And right now, we've talked about it. I think we would support some type of new parameter that was a timeout that would alert people, but we have not implemented that. So right now, if none of the machines can synchronously commit, Postgres will stop committing and it will just hang there, waiting forever potentially. Kind of dangerous, frankly. Yes?
I want to ask you about logical replication.
Yeah.
Can we organize master replication, just subscribe the second database to the first database and first database to the second database, and what will be?
Great. So the question is, can we subscribe multi-master, having one database connecting to another database and the second database also going backward? Yes. So the answer is yes, partially. You can have some tables going this way and some tables going this way, okay? What you cannot do currently is have the two tables that are the same going at each other. That would not work because effectively the row would go back and forth forever. So yes, you certainly can. And frankly, what I've seen people do, this is kind of interesting. So if you have an office in London and an office in Paris, I've seen, what you'll have is you'll have all of the London customers in London, all the Paris customers in Paris, and then you'll have a copy of London in Paris and a copy of Paris in London, and you can create that can be done with inheritance. So you can have a parent, which is customers, and then you can have a child table called London customers and a child table called Paris customers, and you can query the parent, and the parent will see both rows, but you can only update the London ones in London. You can only update the Paris ones in Paris. There's a name for that. It's called, I think, selective replication. So you're splitting your data apart and you're replicating some of it in one direction, some of it in another, and then you're making sure changes only happen in one place. So that's a very common solution, and actually this logical replication makes that kind of solution very easy, I think, to do. We have talked about doing multi-master replication with this. I think that's coming. Some people at Second Quadrant are working on it. I'm not sure how far they are. The problem, if you take a look at this syntax, this is a very easy syntax, right? And we spent a long time getting a syntax that we thought was really simple for people to use. And actually, I've heard many people say, wow, this is really easy. Multi-master is always a problem because if two people update at the same time, you're going to have a conflict. So you're going to have, when we implement multi-master, you have to have some conflict mechanism that reports conflicts and resolves them somehow. And every organization is going to do that slightly differently. So it's kind of hard. I think we'll do it someday, but we're not sure exactly how to do it. The other problem with multi-master is, of course, it doesn't give you much speed improvement because all the queries have to happen on both machines. So multi-master is really good if you have very distant servers. That's really, I think, we've kind of come to the conclusion that unless your servers are very far apart and you need to have Asia data in Asia and European data in Europe and US, North American data in North America, that's a very good use for multi-master replication. But if your servers are close, multi-master replication is probably more a problem than it's worth, because these conflicts can cause all sorts of locking problems and data consistency problems. So many customers want multi-master replication. We get this request all the time. But when we start to explain, okay, but you're going to need to create a staff to manage the conflicts, they say, what do you mean? And they're like, well, you know, you're going to have these cases where somebody's updating the same customer in 2 locations. You're going to have to pick up the telephone and talk to these people and find out which one is right and figure out how to fix that. And it's going to happen over and over again. And then they, okay, and then they try it, and then they give up. And they give up on multi-master. I've seen that happen a number of times, because a lot of organizations over-design their infrastructure. They don't understand how complex data problems can be. So they just say, oh, we're just gonna, you know, we're gonna have 5 levels of this and 3 levels of that, and have a big diagram and so forth. And the more complex your infrastructure is, the more easy it breaks. And that's why a lot of the solutions in Postgres are very simple, like this syntax here, because the simpler the implementation, the easier it is to manage, the fewer things that can go wrong. And that's why multi-master, as good as it sounds, is often not implemented very often, except for geographic distribution, when you want your data near your customer. That's the one that multi-master makes a lot of sense. Other questions? Okay. Number 6, this is also an item that I have been pushing for several years. Postgres obviously has a very long history of transaction processing, order entry processing type of queries. You know, your basic website, ordering products from a warehouse, that type of data use. But we're increasingly seeing people who want to use Postgres for what we call data analytics. That is the ability to analyze large amounts of data and to produce very sophisticated reports. I'll be talking about window functions in the next hour, and that's a data analytics feature. But another feature that's been missing in Postgres is parallelism, because as you get larger and larger amounts of data, there's an increasing need to do these operations in parallel, to allow parallel systems to run, basically to process. So instead of my having to process 10 million rows, I can have 10 processes, each processing 1 million rows, for example. So in Postgres 9.6, we added the first aspects of parallelism. And in Postgres 10, we have additional parallelism, particularly B-tree parallelism, bitmap heap scan parallelism, and merge join parallelism. So again, this makes Postgres much more capable in processing large amounts of data. In the old days, people had their transactional database, and they had a data reporting, data warehouse database. You probably heard the term. So they'd have separate computers for their transactional work, and then another computer for their analytics work. But the problem is that the analytics data was always old, because they always had to copy the transactional data to the analytics machine. You know, so every night you transfer it over, and then you'd run your analytics that day, and then you'd erase it, and then you'd move it. It was just a very awkward system. So people are increasingly don't want to do that. I don't blame them. They want to run the analytics on the same server as their transactional data. Makes complete sense. And in fact, that's what this feature allows you to do, is to do analytic processing on a transactional server. Questions? Yes. So the question is, do we have any plan to support GPUs? That's right. So yes, we do. There is currently a server-side language called PL-Strom. I know I can't spell it, but it's PL, and then the word is STROM. And PL-Strom is a server-side language that can access a GPU. It's developed by a gentleman in Japan who works for NTT, has been working on it for several years. The challenge of using GPUs is that traditional GPU devices have memory that is separate from the main memory. So because databases deal with a lot of data, right, you've got to, if you want to use a GPU, you have to copy the data into the GPU, process it, and then copy it out again, right? And that has limited GPU use for databases. Now, there is some new technology for GPUs that allows memory that can be seen by both the primary CPU and the GPU at the same time. IBM Power Series, for example, has, I don't remember what it's called, but it's a special capability where you have a certain amount of memory that the CPU can see and the GPU can see. And in that environment, it becomes efficient for you to use GPU instructions. We haven't done any more work with that. Certainly we could potentially do sorting on the GPU, for example. But PL-Strom is probably the most common GPU implementation for Postgres. Other questions? Okay, great. Okay, number 7. This is one that I am personally very excited about, although you may not be, but that's okay. This is one where, again, I've been with Postgres for 21 years. We inherited the optimizer code from Berkeley, and very early on it was clear that the optimizer was not, it wasn't great. It was okay, but it needed a lot of help. So in the past 20 years, we've done quite a bit to improve the optimizer. And of course, the optimizer is the brain of the database. It's the part that figures out how to quickly execute a query, whether it's choosing an index, choosing a join method, choosing what order to join the tables in. The optimizer makes those types of decisions. And if the optimizer isn't good, queries can become very slow. So all relational systems have an optimizer. Some optimizers are better than others. Because we're open source and because we have some very smart people, both here in Russia and in other countries, our optimizer is really good. It's certainly as good or better than the commercial databases now. And that's saying something. In fact, there's a lot of things in Postgres that are better, frankly, than a lot of the big commercial databases. And one of the reasons that we've become very, very popular is because we have very good technology. But there's always been one area that we've had trouble with in the optimizer. And that is a case where you have two different columns that have some type of relationship to each other. Now, to back up, Postgres creates something called statistics for every column. So every column in Postgres has statistics, what we store in the database, and we store information, for example, the 100 most common values in that table we store in the statistics, and we have a histogram for that column. How many A's are there, how many letters begin with D, and so forth, or how many customers from 1 to 100, and how many from 100 to 200, that type of histogram. And the optimizer uses those statistics to figure out what indexes to use, what join methods to use, and so forth. The problem is that the statistics are in single columns. So for example, if you have a city column and a country column, we would have individual statistics for city and individual statistics for country. So if I said Moscow, Russia, well, that's very common, right? If I say Moscow, Finland, there's probably no Moscow, Finland, right? So there's an example where knowing that Moscow is popular really doesn't help me because I don't have any statistics that talk about Moscow and Finland together. I just know about Moscow, and I know how common Moscow is, and I know how common Russia is, but I don't know how common Moscow, Finland is, or Moscow, Russia. Those certainly are, one is very common, one is not common at all. So the idea of create statistics, this new feature, is to allow us to generate statistics on several column combinations. The advantage to this is that once you create these statistics, the system knows Moscow, Russia is common, Moscow, Finland is not common. And that information can be then used by the optimizer to choose a better executor plan. And that is obviously very useful. Probably 90% of the problems or complaints we have about the optimizer are related to multi-column statistics. And it is the hope that this Postgres 10 feature will improve that. In Postgres 11, I think, will have even better statistics, so we're still improving it. But this is sort of the direction we're going in, so that you don't have to put hints. You don't have to put hints in your query. You can create statistics, and all of your queries will automatically use the right plans, the right indexes. Any questions about that one? Yes?
Do we need to create multiple statistics manually, or it is automation procedure?
Yeah, that's a great question. Do we need to create these statistics manually, or does it know how to do it? Right now, you have to manually create the statistics. And what I would like to see is some kind of advisor tool which would look at your data distribution and the queries you're using and identify places, suggestions of where you might want to create them. Right now, this is a brand new feature. We don't have that. But I do think that's where we need to be going, because people may not know about this and where it's important. You kind of have to look at how often you're querying multiple columns from the same table, and also in what cases are those columns correlated. So you have to almost do two things. You got to look at the queries, and then you got to look at the data distribution. Sometimes data distribution is just normal and you don't need to do anything, but if it's Moscow, Finland, Moscow, Russia, that would be very unusual. So you almost have to do a very complicated analysis to make that suggestion. And I think we still have work to do there. Good question. Other questions? Okay. Number 8, this is a feature that we originally added in Postgres 9.6, which was the previous release. It's something called wait events. Wait events allow you to see what Postgres is doing internally. If it's waiting on something, we have a system view called pgstat-activity, and pgstat-activity will show you what is being waited on. It'll show you kind of what's being waited on. So we had this in Postgres 9.6. What we did add in Postgres 10 were additional wait events, things like client reads and writes, so network overhead waits, reads and writes to the operating system, fsyncs, and even replication waits. So here's how you would use this tool. Up at the top, we have a query. The query is querying pgstat-activity. pgstat-activity is the name of the system view. And down there at the bottom, in black, at the bottom here, it tells you that we have three sessions waiting on a transaction ID lock, and 19 of them waiting on a wall write lock. These are features from 9.6. And up here in red in Postgres 10, we have new wait events, client read, and data file write. And these are basically, this is new output, new types of wait events for Postgres. One of the things I'm proud of is that the wait event API is very easy to use. It's always enabled. There's no overhead. There's no slowdown. So anytime you want to look at wait events, you just look at them. That was one of the major design goals of Postgres, that these wait events would be enabled by default and always available. Some debugging tools you have to turn on and then look at them, and that we just found that to be very inefficient. So this is a very clean, light way of seeing what's happening in Postgres, and people seem to be very happy with this. We did have a lot of Russian discussion about this, and the Russians helped us to implement this particular feature, and I think it's a great API. I think. Questions? Number 9, Postgres has a number of authentication methods. We support about 10 of them. So LDAP, SSPI, let's see, Kerberos, Radius, password, whole bunch of them. SSL certificates we can use. One of them that we've used for many years is called MD5, originally implemented about 20 or 18 years ago. MD5 kind of showing its age. The random number we used to prevent replay was only 4 bytes, so after 64,000 connections, that potentially you could request the same random number and then somebody could replay the packet. I'm not going to go into details, but new in Postgres 10 is a new authentication method called Scram. Scram is an industry standard way of sending passwords back and forth over a network that is secure. Even if the network is not secure, the passwords are properly hashed and salted so that somebody cannot see the password and somebody cannot replay the password. That's kind of the goal. Okay, so again, for those people who are using MD5 to send passwords, Scram is our new method. We do have something called in Postgres 11 called Scram with channel binding. I'm not going to go into that, but Scram with channel binding gives us a way of preventing man-in-the-middle attacks with Scram by binding to the TLS parameters. I know it's getting way into complicated, but that's an even nicer authentication solution coming in Postgres 11. Okay. And finally, this is again to the gentleman who asked the question earlier about sharding. We have been moving forward with our sharding solution. The concept here is that you have queries coming from clients at the top, and you have basically a coordinator server which knows where all of the shards are. Here's 3 shards down here with 1/3 of my data each, and the coordinator can automatically send the queries down to the shards and retrieve the results back. Okay, this is sort of a big data architecture that we're working on that we probably have another year to go. But my company, Enterprise DB, and NTT in Japan have been working very hard on this type of data architecture, and I think we're going to see some really nice results in the years to come. Just to be specific, one of the features that we needed in Postgres 10 was partitioning. So to do sharding cleanly, we needed a partitioning syntax, so that's why one of the reasons we implemented the partitioning syntax. Not the only reason, but a reason. Another thing that we've been working on are something called foreign data wrappers. Foreign data wrappers have been in Postgres for a while, but effectively foreign data wrappers allow us to send queries to other servers and retrieve results back. In Postgres 9.6, we added the ability for joins to be sent to foreign servers and the ability for sorting to be sent to foreign servers. In Postgres 10, we now have the ability for aggregates to be sent to foreign servers. So this would allow us, for example, if we want to know how many customers we have, I can send a count query to each of the 3 servers. I can retrieve the result of the count, and then on the coordinator, add those 3 numbers together and return them. So this is sort of our first sharding solution for data analytics. You can push these aggregates down. Aggregates are processed on the shard servers. Then the results sent back up. One missing piece, frankly, is the ability to send foreign data queries in parallel. So right now, unfortunately, it's going to send each query to one server, wait for the result, second server, wait for the result, third server, wait for the result. That has to be improved. And I'm hopeful in Postgres 11 that we can do that. So that's probably one of the missing pieces, I think, for sharding. Okay. 5 other items that didn't make it onto my list for Postgres 10. Better row-level security, after full-text search for JSON and JSON-B, schema default permissions, and some other things. Pretty interesting. And finally, in Postgres 11, just to give you an idea of what we can expect in September, October, as you may know, Postgres has had server-side functions for many years, but we have not had procedures. A procedure in the SQL language is one that has the ability to start and commit transactions independently. You cannot do that in functions. And also the ability to return multiple result sets, which is another capability of procedures. So this is one feature coming in Postgres 10, are procedures which have transaction control. The second one, which may have you scratching your head, as I just did, is JIT compilation of the executor. As I may have mentioned before, Postgres has a parser, an optimizer, and an executor. And the executor is this part of the system that runs the query. And the executor is a very complex state machine where you're basically running a recipe that came from the optimizer. We call it a plan. And because the recipe can be very complicated, there's a lot of function call overhead, there's a lot of sort of internal processing as you're going through millions and millions of rows. Unfortunately, in the C language, when you're jumping around from function to function all the time, that can slow things down. So the idea in Postgres 11 is that we now have a just-in-time compiler, very similar to the way Java uses a JVM. And it allows you to basically take the plan that comes out of the executor and compile it to assembly language. And you are then running the executor state machine in assembly language instead of in C. So we've seen some major speed-ups, again, mostly for large data workloads. But this is a very exciting opportunity, I think, to speed up Postgres. There are a number of research projects that have used this, but the main Postgres tree will have it in the next release. I mentioned parallel query. Of course, we've continued to improve that and create index. The ability to create indexes in parallel is coming. Okay. And finally, to finish out, I mentioned that we're continuing to work on partitioning, and sort of related to item number 2 that we talked about earlier, we will have hash partitioning in Postgres 11. We'll have partition-wise joins. We'll have executor stage partitioning. So again, the ability to prune at executor's time instead of just in the optimizer. We'll allow rows that are updated to be moved from old partition to a new partition. We'll have a default partitioning capability, and foreign keys will be allowed to be pointed into partition hierarchy, which is, again, a kind of a new feature. Okay? Any questions? So as you can see, we got some really nice stuff here. Postgres 10 had a good list of features, and I think Postgres 11 is looking pretty much the same in terms of a very robust, significant set of features for this release. So what I'd like to do is take a couple questions, then we'll take a break. And when we come back, we'll do window functions. I think that's the plan. Is that correct? Yes, I'm getting a nod up there. Anyone? Yes, sir.
Maybe finally question. Is it hard to migrate from Postgres 9 to Postgres 10? Maybe do you know any issues or problems connected with migration from Postgres 9 to Postgres?
Great. So the question is, are there any issues with migrating from Postgres 9 to Postgres 10? The answer is really no. I should have talked about this earlier. The reason that we renumbered from 9 to 10 is not because we made any significant change, but people were confused that Postgres, that the major numbers were two numbers. So from 9.0 to 9.1, that was a major release. And from 9.5 to 9.6, that was a major release. And people didn't understand that the first two numbers were the major number and the third number was the minor number. And that just confused people. So we said, fine, we'll just go with one number, 10, and then the minor number is now the second number, right? So the next one is 11, the next one is 12, and so forth. So it was really just done to simplify the numbering. There was no real functional difference between 9.6 and 10. The same amount of changes happened between 9.4 and 9.5 and 9.6 and 9. So you shouldn't see any difference in terms of migrating at all. Yeah, good question. Other questions? Yes. Yeah, that we've. So the question is, will upgrading is difficult for Postgres? Are there any new, easier ways maybe to do upgrades from Postgres 10 to Postgres 11 using logical replication? I have talked about that. In fact, I talked about that in Moscow a couple days ago, had a long discussion. I think that for the short term, PG upgrade is probably going to be the easiest way to upgrade your servers. You can use logical replication to do the upgrade, but because logical replication is only table by table, okay, you would have to make sure that you set up logical replication for everything, every table, and every index had to be exact, it had to be copied over, and you can't make any changes while you're upgrading. But potentially, if you're willing to set up logical replication and have everything copied over, and also all the DDL, every time you change something, you're gonna have to do the same DDL on the other side. Effectively, you could migrate so that you're running Postgres 10 and you could be running identical Postgres 11, and you would then just shut down this server and make this the primary, and then you would be able to upgrade. So I think logical replication makes it a little shorter downtime to switch over versus PG upgrade in link mode, for example. But unfortunately, logical replication is always going to require more work in terms of having to have two copies of the data, having to make sure those two copies are absolutely synchronized when you do the switchover. And I think that's the challenge for administrators. We can reduce downtime a little bit because PG upgrade in link mode is going to take maybe 3 minutes or 5 minutes. And there's some systems that can't do that. in those cases, logical replication would be a way, because you can replicate from the old server to the new server, and they can be on different major versions. And that's definitely a possibility. But I don't think it's going to be easier. It's just going to be maybe less downtime to do it. Good question. Other questions? Yeah.
I have a question about query optimization. Does the Postgres still kind of optimize the queries with a lot of joins? For example, 10 or more tables. It goes into the nested loops.
Okay, so the question is, how does Postgres handle joins of very large tables? Is it having the tendency to favor nested loops for very large table counts? I have not heard people, I've heard people complain about nested loops, but I've not heard them complain about nested loops exclusively with large table counts. So it just might be the way your data is laid out. We have heard people complain about nested loops. Sometimes setting either random page cost or effective cache size will tell the optimizer that this is a large machine, it has a lot of RAM, it does random I/O very quickly, and in those cases it might have a tendency to favor a hash join in that case. The problem with hash join is that you really want to have one side of that hash join fitting in memory. Whereas nested loop, it's not as critical. So it's not really it's not really a certainty that we should just avoid nested loops. If there's particular queries that are causing problems, we can take a look at those. If you send them to the email list, we would certainly analyze to see why that might be happening. It may be incorrect estimates, and it may be incorrect estimates because of statistics. It may be correlated statistics, right? So there's a bunch of reasons that Postgres might not do something right. Usually it'll have a tendency to do a nested loop if it thinks the row counts are very low. But if the actual row counts are very high, that would be a case where the statistics are incorrect. Or more likely, it's maybe a correlated, maybe you're querying two columns in the table, the two columns are correlated, the system doesn't know it, it's getting an incorrect estimate. And that's where the create statistics would come in to help with that kind of query. So it's hard to say without looking at the queries, but I don't know of any work being done to favor nested loops one way or the other. Effective cache size and the random page cost are often useful, and the create statistics might help if you're doing multi-column restrictions. Great. Yes?
So talking back about logical operations, as I could understand, we can subscribe a single table to multiple tables, yeah?
Mm-hmm.
So are there any known issues or warnings about concurrency or conflicts of constraints, and who is responsible for conflicts resolution, the user or the database?
Yeah, great question. So with logical replication, you can send multiple tables from one place to another. How would you handle conflicts in this case, or conflict resolution? I'll give you, I think, what the question is, or the idea. What's very interesting, and I only learned this when I spoke in New York maybe a couple months ago, and somebody pointed out that you can have multiple servers sending data to, you can have multiple servers sending data to the same table. Okay, I wasn't aware this was possible. I thought that you could only send, if you had 10 servers and you wanted to send them to one server, you had to create a table for each server, I thought, right? Turns out you don't have to. You can have one table collecting data from all 10 of those servers, and all the rows will go into a single table, not a hierarchy of parent-child inheritance or partition tables, but in fact, into a single table. So the way that works is that when you create logical replication, you might notice that you have to create a primary key. That is a requirement for logical replication. So effectively, if you had multiple table servers sending data in and you had the same primary key value on different servers, as those rows came in, they would overwrite each other, right? So an insert would just overwrite whatever it was, because effectively you're funneling them in. The first row would overwrite the row prior to that. There's no way of detecting that, I don't think. I think it would just throw an error. It would just overwrite it. So when we're doing replay of logical replication, we're just going to look up the primary key, and it's an insert. We're just going to overwrite whatever row that was. When you do an update, what's going to happen is that the copy of the row on your local machine is updated, and then that's sent to the standby, and it basically gets overwritten again. So you could effectively have different versions of the row and different, I could update my copy and you could update your copy, and our rows could look completely different, and one would just overwrite the other one. There really is no mechanism currently to identify, oh, this server created this row, so this other server shouldn't change it. There is no mechanism for that. So what we normally tell people to do if they want to do this kind of system is that instead of using primary key, as I've done here, you would create a sequence. A sequence, internally, primary keys are sequences with defaults on the column. And you would create a sequence, and you would tell it to skip every 100, maybe. So I would have a sequence. It would always start with 1 out of 100. And the second server would always start with 2 out of 100, and third server 3 out of 100. So therefore, every row that came from server 1, the last 2 digits would be 01 of the primary key. And the second would be 02, and so forth. And that way, I could intermix the rows, but I'd be guaranteed that none of these servers would overwrite each other. And fortunately, once you define the sequence and you define the cycle of how much it increments, the increment value, you would say start at 3, increment by 100. So it would go 3, 103, 203, 303, 403. And you would never get conflicts. So that would be the architecture I would use probably for that particular case. Yeah, it's a very interesting question. Other questions? Yes?
I want to ask you about full text search for JSON.
Mm-hmm.
JSON feed. Is it possible to use really SQL language for JSON field, or when you will go to add? Now maybe in Postgres 9 we should use function for aggregate JSON, extract JSON, and it is very big and hard to understand queries. And I want to use really SQL for JSON.
Okay, so the question is, when will we be able to use JSON? Or I assume you're saying you want to use JavaScript natively in Postgres to manipulate the JSON?
Just to select something from JSON like a table.
So select something from JSON like a table. So we do have JSON to record, which will convert the JSON value to a row. Is that?
If JSON collected a lot of records,
Yeah.
we need to extract this JSON into a table, select something, maybe aggregate something, collect something, just maybe collect with maybe reps into our table, aggregate to a JSON, put to another table, and something like this.
I see. We do have some work being done there. First off, the SQL Standards Committee has created a new JSON standard, and Postgres Professional has been working on, I think it's called SQL JSON, Yvonne, is that right? Yeah, SQL JSON. So it currently is a plugin to Postgres, I think, which will allow you to use the JSON syntax, the SQL standard syntax. Yvonne is coming to save me on this question because I'm not sure I know the answer, but I don't know. And then, the other option we do have is PLv8, which is a server-side JavaScript language. But he probably has a better answer, much better than mine.
Thank you. So about JSON. SQL JSON is a part of new SQL standard. Что-то я по-английски говорю, извините. SQL JSON – это в стандарте SQL 2016 появилась поддержка JSON. Это написал Oracle и Microsoft, потому что им уже тоже захотелось поддерживать JSON, как и в Postgres. В Postgres есть там кое-какой синтаксис для работы с JSON. Для того, чтобы по нему быстро искать, есть расширение JSQuery. JSQuery. Оно на GitHub свободно доступно, берите и пользуйтесь. И, в принципе, все то, что может, или там почти все то, что может этот стандарт, уже есть в JSQuery, но по-другому, потому что раньше сделали. И вот теперь задача в том, что вот этот стандарт, он вот такой вот толщины, значит, прочитать, понять и поддержать. Это не экстеншн, это будет закоммичено в основной Postgres, и что-то уже даже лежит на коммит-фесте, и есть некоторая надежда, что в 11-ю версию оно попадет. Вот.
And the longer answer to this is that we're continuing to improve the JSON API to Postgres because we know it's very important, very useful. But one of the really, I think, exciting things about Postgres is that when it was designed at the university 30 years ago, it was designed to be extendable. So if you notice, PLv8 and PL-Strom for GPUs and JSON and new JSON APIs and full text search and GIN indexes and all these other things. Postgres is really good at changing based on what somebody needs. PostGIS, another one. So the good news is that we've gotten a reputation for being very flexible and being able to add things to Postgres that make people's job easier instead of being very rigid as a lot of the commercial databases are. So I think that we're continuing to understand how we can make JSON easier to use for people. You're right, the function API is awkward and kind of hard to understand when you're looking at it. Some of the simple things like extracting a key from the JSON, that's very easy, right? But anything complicated, you fall back to functions, and then you've got this weird API. And Postgres has that flexibility that allows us to change it very easily. And I think we're going to see more improvements there.
Да, есть еще такая тема, как синтаксис сабскриптинга для JSON. Это когда вы будете писать update, там set JSON, дальше такое-то, такое-то, равно тому-то. То есть не использовать JSON B set, то есть не присваивать, не переприсваивать как бы целиком это JSON-овское поле для того, чтобы в нем что-то изменить, а писать так же, как с массивами. Там x2 равно 3, также с JSON. Вот. Но эта штука еще не закомичена, насколько я... В смысле, еще не лежит на коммит-фесте, поэтому в 11-й она может и не окажется. Вот. Ну, значит, будет 12-й. Вот. И еще вот тут вопрос-то изначально начинался, как найти JSON, в котором где-то в каком-то месте что-то лежит. Вот как раз расширение JSQuery, оно это сделать позволяет. Более того, он не просто позволяет это сделать, позволяет использовать индекс. То есть можно GIN-индекс делать соответствующим образом. Вот. Поэтому посмотрите JSQuery. JSQuery extension.
Yeah. I mean, frankly, just the ability to do full text search on JSON documents, right? It's like, what? Like, you've got full text search in the database, you've got JSON in the database, now I can do full text search in my JSON document, is an example of some of that, I think, flexibility, which is I think it's kind of cool. So you can actually search inside of a JSON string, which is inside your JSON document. Is kind of cool.
И еще небольшое дополнение. Это было как раз в докладе Олега Бартунова на конференции PGConf Russia только что про гибкое индексирование, flexible indexing. Значит, идет разработка возможности добавлять в создание индекса дополнительных параметров, которые могут как-то, то есть не просто create индекс, а create индекс и произвольные параметры туда. Вот. Для чего это нужно? Например, для того, чтобы индексировать JSON не целиком, огромный JSON, а только нужную часть его. Вот это, соответственно, и сократит, и ускорит индексы.
Yeah, and a lot of that stuff is from Russia. A lot of the indexing and the non-relational features of Postgres that have been very popular come from there. I have a separate indexing talk on my website that kind of explains the different indexing methods. And frankly, the ability to index very complex data like JSON or full-text search is one of the outstanding features of why people use Postgres. Because B-tree just doesn't work for that type of data. Other questions? Shall we take a break?
Тогда перерыв. Let's make a break.
It's up to you.
Which question?
That guy right there has to get it right there. And this guy right here.
About what?
The guy who predicted where my slides were going.
Коллеги, Брюс отметил два вопроса, которые он хочет наградить призом. Значит, первый. Кто предсказал, в какую сторону пойдут слайды Брюса? Yeah. And the second one?
Yeah, it would be that gentleman right there in the blue.
Mm-hmm. So, Bruce, give them this pillows.
Sure.
Вот. Чтобы лучше спалось,
Very good, thank you.
чтобы лучше спалось на работе, надувная подушка. Ну, давайте минут 15 перерыв. 15 minutes.
That's actually a really interesting question. I don't get asked a lot, so I didn't talk about it. And also, I was worried with my time. But basically, I got married in 1989, and I worked as a database application developer for law firms. So I did legal applications. So we write financial reports and pretty boring, right? And I did that for 7 years. So 7 years, I'm working on financial reports, I'm writing SQL, and I'm kind of, at the end of 7 years, you're kind of bored because you're doing the same thing all the time. You're really not growing as an engineer because you're doing the same languages, the same everything, right? So I thought, well, I'm always curious that when I sent this SQL query to the database, how did it work? Like, how did it know what a select was? How did it know? It almost like you could almost read English to me. So I said, I was running Unix at the time, and I said, let me download an open source database, and I can see how that database understands SQL. So I downloaded something called MSQL at that time. It was kind of didn't work very well. And then I downloaded Postgres. And I was like, oh, this is very similar to Informix and Ingress, which are the two databases I used. And I was like, oh, this is really interesting. I can see the parser. I can see the optimizer. I don't understand it, but at least I can see what the database looks like. So,
тут есть книжечки, магнитики, наклеечки, которые можно брать.
As I was starting to play with it,
Пробовать взять автограф у Брюса на книжечке.
I started to find some bugs, like things that just really were pretty obvious. So I'd see the bug, I'm like, oh, this doesn't work, and they would say, oh yeah, we fixed that like 3 weeks ago. Here's a patch. Go back in the email and find the patch, right? And then I find another bug, we fixed that 5 weeks ago. So I'm thinking, why is nobody, like, why, if you fixed it already, why are you not making a new release with these fixes, right? So it looked like a project that had potential, but nobody was really managing it. It was just kind of coasting. It was kind of just going along very slowly. So I said, maybe if somebody helps to organize this thing, we get all the patches from all the old emails, we can actually make a database that people will use.
So the idea is to find a problem and give out and then
That's pretty much what it was, yeah. There was probably 100 users at that time, and once we created an email list and a place to send patches, and saw people taking patches and putting out new releases with their patches, they're like, oh, okay, I'm going to send in more fixes. And all of a sudden, so it's like a cycle. You basically show people that you care. You show people that if they work on this, they'll get rewarded. Somebody will use their work in bettering something. And you do that for 20 years, and you end up here. I can't say the cycle's really changed a lot. And it's the same process where you have a problem. It's usually an interesting problem. People like solving problems, right? And a lot of people are like me. They're in very boring jobs, and Postgres is exciting. The problems are exciting. The people you're working with are exciting. The conferences are exciting. I mean, a great example. I spoke. Alexander Korotkov, who's worked for Postgres Pro, he originally wrote a doctoral thesis at NIFI in Moscow. It's like the nuclear or whatever. I've been there. And he wrote a doctoral thesis about Postgres for whatever reason. And he submitted the doctoral thesis to us. And we're like, well, that's kind of interesting, but you're going to need to make all these changes so we can use it. And he made all the changes, and we added his feature to the next Postgres release. And all of a sudden, we're flying him all over the place because he's now a big guy because he fixed this very hard problem. So he's going to Europe, he's going to the United States. And the university, Beefy's like, what happened? This guy wrote a doctoral thesis. All of a sudden, we're flying him everywhere. What did he do to make him be popular? So they had me come to MEFI, and I spoke for 2 days at MEFI, and I gave a whole bunch of lectures. I went through probably 12 of my presentations over 2 days, and I spoke to probably 40 people. And I left. I was like, oh, that was interesting. Then 2 years later, I'm at a conference in San Francisco. 2 students come up to me and they say, hi, we were at your MEFI lecture, and now we're here to talk about Postgres, right? So that was Anastasia and another person. I can't remember. So the cool thing is that this happens not just now, but it happens continually now, where you go, you talk to people. Some people are not interested, but there's always a small group that say, this is really an interesting problem, and I can see a value to it. And I think the really exciting thing for me is that most engineers are in the back of the company. They're not in the front. Usually in the companies, the people in the front, the executives and the salespeople and the marketing people, and the engineers are in the back. But with Postgres, the engineers are in the front because we don't have any marketing, we don't have any salespeople. So it's really an opportunity, I think, for Russia and for other students to really be recognized around the world for their expertise, and we've seen that a lot even with Postgres Pro. Your company has like a whole bunch of new people that I've never heard of before who are doing some like amazing things, and we look at the email, we're like, whoa, how did this guy do this in a week, right? They just, somehow they managed to do these things, and that's the goal of the project, is you're taking the brains and the skills from all over the world, and you're giving them a platform to grow. And I think that's really that's how we've gotten where we are, and that's why we're just very, very successful now, even though it took 20 years to get here. And I'll also tell you that when you start 20 years ago, you do not believe you'll be right. I mean, I will also tell you that I hid how much time I spent on Postgres for the first couple years because my wife, at that time I was being paid hourly, so every hour I was working on Postgres I wasn't getting paid. And my wife would look at the report at the end of the month, and she'd say, she'd kind of come down really sheepishly to the basement where I worked. She'd say, the report last month, it was a little low, you know, hours were a little low. I'm like, yeah, I know, we had a big Postgres release, and I had to do some stuff, you know, I'll catch up this month. So yeah, she kind of, for the first couple years, I kind of hid a little bit of how much I did. But then I wrote a book about Postgres. I thought, oh, okay, he's writing a book about it. Maybe there's something to this. And then I've been hired, I got a job doing this. I've been doing this full time since 2000. So it's like, what, 19, 18 years now. And I do almost all this. Like, I go to conferences, I work on the community, I read email, and I fix bugs. And I do very little for my company. And nobody asks me anything, and my boss is very nice, and, you know, this is a great job. So, you know, I just keep doing it. So it's a very good question. Yeah.
Thank you so much
So
for
thank you.
this
Appreciate it.
story.
Sure.
Can I ask you several questions for university newspaper?
Yeah, sure.
The first question, why it's interesting for you to come to Russia and to make a lecture for all of us?
Of course. So the Postgres project has a long history of getting assistance from Russian developers. Again, as I mentioned before, I had a very good friend, cousin of ours, who helped me in the early years. Every time I got stuck on something, Vadim Mikhaev would come and fix it for me. So he was very... Mikhaev? So he would always help me. I've since been to Krasnoyarsk. But Oleg Batunov and Ivan and Alexander Brodkov and Fyodor Sigayev have always been very, very helpful and incredibly creative in the features they add to Postgres. So I've always felt there's incredible creativity and inquisitiveness here in Russia. And some of the solutions we get for Postgres can only come from Russia. I don't know how to explain that, but one of my goals here is obviously to thank the Russian community for all that they do for the project, and obviously to introduce new people to Postgres, because potentially they'll want to get involved as well.
So you're looking for a new people for the company, yes?
Well, I'm looking for new people for the community project. I'm going to try and help some people use Postgres who aren't using it already. I'm trying to help some people who are already using Postgres to use it better. So it's kind of a spectrum of things that we're here to do.
And how's your impressions about Ekaterinburg, about the university?
I haven't seen much of the university yet. I have seen, as I said, a good amount of the city. We went to the Church of the Blood, and walking across the river was a new thing for me. Ice walking, and of course the Yeltsin Museum was very nice, and the Banyu last night was very good. So it's been a very packed trip so far, and we're again, as Ivan said, we're hoping to come back.
Okay, so we'll wait here in the fall.
Yes.
Thank you.
Of course.
Thank you very much.
Yeah.
All these models, conceptions like NoSQL and blockchains, how do you think will the concept of relation database lead up and overcome these technologies?
Yeah, that's a great question. So I've been around a long time with relational systems, and there have always been challenges to relational systems. So in the 1990s, object databases were going to be big. And relational was going to go away, and everyone's going to have object databases. Object databases more clearly match like the Java hierarchy. But the problem, there's a lot of limitations to object databases, so that didn't work. Then in the 2000s, it was going to be XML databases, which you might have heard about. Oh, everyone's going to do the XML databases, no more relational anymore. Well, that kind of changed, right? And now we're using NoSQL. And NoSQL, I think, is already on its way down in terms of hype and excitement, and everyone's kind of understanding where a NoSQL database makes sense. But relational is going to be around because relational, from object database to XML database to NoSQL, has been flexible. and has taken the best object databases and XML databases and NoSQL databases and added them to the relational model, and then basically been relational plus NoSQL plus XML. And I think the same thing's going to happen with blockchain. So Postgres already has a blockchain like enhancement to Postgres, so they're already working on that. So the relational model is very, very flexible. And as you can see, it can be changed in a whole bunch of different ways, whether it's Java, JSON, full text search. And I think relational is going to continue because I think it continues to adapt. As long as you continue to adapt to new workloads, you'll probably be successful.
And what do you think about many people who say that, Elasticsearch is much more efficient than Postgres, and there's a relation databases and all?
Elastic, my reply to that is it's similar to somebody trying to create a billing system using NoSQL. Like people have tried it, it doesn't go well at all because there's no data integrity, there's no restrictions on the data, and you end up with just a big pile of data that you can't really process. The same thing with Elasticsearch. If you try to take an average Postgres workload and put it in Elasticsearch, it'll work fine for comments and free form, but you're not going to put any structure around it in any meaningful way. So the question is, the reason relational has been popular is the ability to put structure around the data that needs structure, and also the ability to not put structure around the data that doesn't need structure. And I think both the full text search and the NoSQL cases, and the XML case, frankly, are cases where, and actually the object databases, all the problems with those other ones is lack of consistent structure, no way to specify consistent structure. You can make it optional. It's optional in Postgres because you have JSON, you have full text search, you can store a whole bunch of data in Postgres that isn't structured. But if you're going to do anything with your data, it's got to have some structure because a bunch of data with no structure is almost useless. Right? So when you're really looking at the problem, you've got to have a structure, and the question is, what tools does that database give you for structure? And is it a requirement or is it an option? And I think early versions of Postgres, there was no option for non-structured data. You only have structured data. Now in Postgres, you have structured data and you have non-structured data. When you look at NoSQL or you look at full Elasticsearch, their only option is unstructured data. And without structure, you can't do joins, you can't do referential integrity, you can't really kind of make efficient use of indexes and stuff. So the whole thing becomes really kind of hard to do anything.
Yeah, thank you.
Sure.
Postgres community works with companies that provide measure support for its client.
Yeah.
For example, Postgres Professional some proprietary stuff for its clients.
So I go down there and I just hit them a couple times, and that's how we do it. Yeah. No. So the way we do it is that Postgres is BSD licensed, so there's no restriction on what you can do with it. So we have Aurora, Amazon uses it, my company has a proprietary version, Professional has a proprietary version, Quadrant has a proprietary version.
And all the proprietary companies share as a result of its...
Exactly. So what effectively happens is that the community is so powerful, okay, that Postgres Professional and Enterprise DB are making small changes to the database to match the needs of their specific customers, like blockchain, or I want Oracle compatibility in this area, whatever. But the core server is so powerful, and the features every year are so good that they just continue every year. They just say, here's a new release of Postgres, I'm going to add my little extra thing, and then when the next release comes, I'm just going to add my little extra thing again. And it's a kind of thing where it's kind of like you're on a ship and you're going going out fishing, right? Everyone's got their own fishing pole, but you're all on the same ship, right? And that's kind of the way we are. We all paid to get on the ship. We're all helping each other. If you need if we're fishing and you get a fish and you need help pulling it in, I'm going to help you pull it in, right? I'm going to get the basket down there while you're pulling the fish up and get it out of the water. And that's kind of the team that we have, this sort of philosophy behind how we do things. So I went to Postgres conference in Moscow. I go to Second Quadrant conferences. Second Quadrant comes to our conferences. They come to our conferences. So it's like we're on the same ship, but we're fishing different.
Нам пора уже начинать следующую лекцию. Мы Брюса еще не отпустили даже пройтись. Вот.
We have 5 minutes. For what? Because we were supposed to end at 1 o'clock. So how does this work?
No, we have unlimited.
Okay, but you need to tell the people we're going to go to 2 o'clock because unless they think they need to one at 1. Because I said we were going to do it for 2 hours. And it's 2 hours already.
Yes.
You with me?
So just make your lecture, I think, with regular rates.
Okay. But do you want to tell them or you want me to tell them?
I will ask them.
Yeah, you ask them. That's good. That's very.
Ну, сейчас начнется вторая лекция Брюса. What is your second lecture about?
Window function.
Window function.
Okay, welcome back, everyone. Very nice. I had some very nice discussions down here with people. They're very good questions, so that was a great pleasure. Thank you. I had said that I was only going to be here for 2 hours, but it is 2 hours almost. So it looks like we may be here for 3 hours, another hour maybe, to do this lecture, if that's okay. I just wanted to make sure everyone was aware that we'll probably be here another hour, I guess to 1430, something like that, if that's okay. Good. Okay. Thank you. I guess I didn't plan my hours well. As I said before earlier, one of the requirements of Postgres is the ability to analyze complex data. Historically, people would have a separate transactional database and a separate data warehouse analytics database, but that's proving to be less popular, and people want to do their analytics in the same database as Postgres. So what I'm going to talk about today are effectively something called window functions. Window functions are part of the SQL standard, and Postgres implements those in the standard. So whether you're using Postgres or some other relational database, if that relational database follows the SQL standard, then you'll be able to use the queries that I show you. Okay? So let's talk about window functions. Window functions are one part of a larger list of features necessary to do analytics in a database. So if you think of aggregate functions like count and sum, you think of server-side languages, you think of table spaces and materialized views, common table expressions, things like grouping sets and parallelism and sharding. These are all part of data analytics inside of a database. And almost all of these are implemented by Postgres, except for the last one, which we're working on. And window functions is just one of the aspects. So what is a window function? This is a text actually from the Postgres documentation. And as you can see there in pink, we have a URL that takes you to that documentation. I should also mention that this presentation is on my website, just like the previous one. And I think there's even a video of me delivering this presentation on my website. What is a window function? There's a lot of text here, so I'm not going to read it. But in short, when you normally use something like an aggregate, like a count or a sum, you expect it to take multiple rows and reduce it down to a single row. So if I say count of a table, I'm going to get one row back. No matter how many rows are in the table, I get one row back. If I ask for the sum or the average, no matter how many rows in the table, I get one row back. If I use a group by, I get one row per group, okay? But the idea of a normal aggregate is it takes a bunch of rows and it aggregates it down to a smaller number of rows. Window functions give you similar capabilities to aggregates, except that they do not reduce the number of rows returned. You can see it right there. So basically, it says window functions do not cause rows to become grouped into a single output row like non-window aggregate calls would. Instead, rows retain their separate identities. And I'll show you some examples of this, but there are a large number of data analytics cases that need the functionality of window functions. Another aspect that you should be aware is a lot of this text has there's a lot of these slides have a lot of text on it. So you should be looking at the red text on the screen. Wherever you see red text, that's where you're like in this picture. Okay, so here's some red text right there, right here. So that's where you're going to want to look. Effectively, this is not a window function. This is just a function. This is a call to a function called generate series. Generate series effectively just generates numbers from 1 to 10. Okay, so select star, generate series 1 to 10, it just generates all the numbers 1 to 10. I'll be using this query in my presentation, so that's why I'm showing it to you. Also, at the bottom is a URL, and that URL contains the queries that you're going to see in this presentation. So every query you're going to see is in that SQL file. So if you want to download that SQL file and run it, you'll see my presentation sort of fly off the screen as it executes every query that you're going to see in this presentation. In fact, the way I wrote this presentation was to write the queries and then run the queries, capture the output, and copy it into the presentation. Okay, so these presentations are literally from running them in PSQL. Here's our first window function. The reason I know it's a window function is because it uses the word over. So anytime you see the word over, it is a window function. Okay? And what might be surprising is you see the word sum, which you're probably familiar with, and you're adding the word over in addition to that. Okay? So it's sum and over, and then in parentheses, we just have the empty set, like the defaults. So I have to put something there. I just put open parenthesis, close parenthesis, and that is my window function. Okay? And as you can see in the output, We have the numbers from 1 to 10. And then we have the same constant for every row. That's kind of weird, right? I asked for a sum, but it didn't give me one sum. It gave me a sum on every single row. The reason is because I used a window function. As I said before, window functions do not reduce the number of rows output. It keeps it the same. Why is it a 55? Well, turns out if you add the numbers from 1 to 10, the sum is 55. Okay? So that's why we get a 55. And we get a 55, in this case, on every single row, which probably is pretty useless. There's probably not any use to this, but you get the idea. Okay? That's a very, very simple window function, and it has not reduced the number of rows. It's allowed me to compute the sum, and it allowed me to put the sum on every single row. Okay? Here's another window function. Here we're doing a count and a sum. So we have a count. Here's 10. Here's a sum. There's 55. Okay? And notice there's two over clauses. All right? Here's another one. But instead of having to say over and parenthesis, what I did was I created a window clause, and I named one of the variables W, and I made it open parenthesis, close parenthesis. Now the W represents open parenthesis, close parenthesis. All right? Again, really no use for this, but I'm showing you an example of how you can use a window clause to kind of collect everything together. Okay? You might have wondered why the parentheses are there. Parentheses are there for the ability to specify something called a window frame. Window frame, in this case, is the text in red. These are the default values. Okay? Range between unbounded preceding and current row is the default when you don't specify anything for the window frame. Okay? Any questions so far? I will let you know that this presentation starts very slowly. So we're going to be kind of going very slow. It's going to appear very useless. And then all of a sudden it starts to climb. And by the end it gets really complicated. Okay? So just be aware that the initial part of this presentation is much simpler than the later part. Okay? But we have to, unfortunately, go through this initialization period, introduction period, so that when we get to the complex stuff, you understand what's happening. All right? Questions? No? Okay. So let's look at the window syntax. The window syntax from the Postgres documentation, which we're listing there at the bottom, effectively has a number of clauses, partition by clause, which we'll see later, an order by clause, which we'll see later. We have a range or rows clause, and then a frame clause. Okay? And the frame clause can actually contain any of these words. Again, this is really very trivial. Doesn't mean a lot yet, but it will. I promise you. I mentioned that this is the default window clause, range between unbounded preceding and current row. Notice that the default window clause has no partition clause, partition by clause. It has no order by clause, and it uses the word range. Range and rows have special meaning. I'll be talking about that in a minute, but that currently is the default. The first complexity that you might have suspected is the meaning of current row. Current row in the SQL standard does not always mean the current row literally. And this is a common cause of confusion. I will say that I started working on this presentation 6 years ago. 6 years ago, we added this feature, and I thought, oh, it would be very nice to have a presentation about window functions. And I started working on it, and I became so confused that I gave up. And this summer, I had some time. I wasn't traveling. And I said, let me go back and look at this again. Maybe I can figure it out this time. And fortunately, I did. So one of the aspects I found was that when you say current row, the meaning of those two words changes in various situations. In fact, I've had people come to me who have used window functions for years, and they said, I thought I understood window functions, but now I realize I didn't until I saw your talk. Because it's just a very odd standard, and its behavior is kind of odd. So just to give you the first complexity, current row can mean three things. It can mean the literal current row, which is what you would assume it means. It could mean the first or last row with the same order by value. So for example, if I order by a value and the current row is 3, current row could mean all of the rows that have a value of 3, not just my row, but any row with a value of 3. And that would happen if you're in order by mode, if you have an order by, and you're in range mode, which again, getting very complicated. Or current row could mean the first or last row of the partition. So it could mean, even though you're saying current row, it could be the last row, not the current row. And this kind of problem really gets to the heart of one of the complexities of this syntax. To be a little more verbose, current row means the literal current row if you're in rows mode, if you use the word row, the rows clause, which is not the default. It can mean the first or last row with the same order by value if we're in range mode and we use an order by. And it can be the first or last row in the partition if you're in range mode and you do not use order by. And I have examples of all of these in future queries. Okay? Giving you a little graphic example, the first one on the left is the literal current row. Okay? The second one is the current row in range mode. And the reason this is true is because you'll notice there are 2 3s here, and the current row encompasses both this row and the next row because they both have the same row order number value. Okay? It could be from the beginning of the frame all the way to the literal current row. It could be from the beginning of the frame all the way to the end of my peers, or it could be the entire partition. Specifically, and again, don't expect you to memorize this. This is the literal current row with this syntax. This is all of your peers with that syntax. This is from the beginning of the set to the literal current row, beginning of the set to the end of my peers, and this is the entire set. Unbounded proceeding to unbounded following would be the full set. Okay. Any questions? Okay. Again, we're starting slow. We're moving up. All right. So we're gonna now show you window queries using the standard aggregates, and we're gonna illustrate all of the features that I just talked about. Okay. So this is the query I showed you earlier. Remember the one that had the 55 all the way down, and the one that has a 10. So it's the count, right, and the sum. And the thing to realize here is that we are doing this in range mode. Okay, and remember I said in range mode, without an order by, the current row is the last row in the partition, the last row potentially in the set. If I change range mode to rows mode, the results change. Okay, so there's range mode, there's rows mode. What is happening? Well, the count looks kind of weird now. The count is exactly the same as the values here. That's kind of weird. But what about the sum? So the sum from unbounded proceeding to current row in rows mode is literally from the first row all the way to the current row. So it's 1 is 1. This second row is 1 plus 2 is 3. 1 plus 2 plus 3 is 6. 1 plus 2 plus 3 plus 4 is 10. 1 plus 2 plus 3 plus 4 is 5 is 15. All the way down to 10, which we know the sum of the first numbers is 1 to 10. Okay? So by changing range to rows, I've now changed the meaning of current row, and in fact, the system now looks a little more normal. I'm going from the beginning all the way to that current row. We do have a default, because again, the default is unbounded proceeding to current row, so I could just put rows unbounded proceeding if I want to. I get the same result because current row is the default for the ending spot. Okay? Here's a different one. This is rows between current row and current row. And you know, you get exactly what you expect. You get the current row. So how many rows do I see on this row? 1. How many rows do I see here? 1. How many rows do I see here? 1. Right? Because each row is only seeing itself, and in fact, that is here, this is there, all the way down. Okay? This actually makes sense to me. There's some of them that don't. This one makes sense because it literally is copying, doing exactly what it seems to say. Now, again, these are all very trivial queries. We would normally be doing sophisticated things. In section 5, we'll actually be going through an employee example, and I'll show you window functions using this employee example to show you a real-life example of how you would use these window functions. I could just say rows current row, and because current row is the default for the end, it returns the same result. Okay. I could do this. This is rows between current row and unbounded following. Right? And I basically flipped it over. Instead of summing from unbounded proceeding to current row, I'm going from my current row to the end of the set. Okay? So 55 is literally the sum from 1 all the way to 10. And the second row is 54 because it's 2 all the way to 10. Okay? And then this is 3 all the way to 10 all the way down. And for the last row is 10 because it's 10. Right? 19 because it's 9 plus 10. So we just flipped everything around. Here's a more interesting case. We're now doing rows between one preceding and current row. So the row before my row. So now you notice that the first row only counts 1 because it doesn't have anything preceding it. There's nothing before the first row, so it's just 1. All the other rows are literally processing 2 rows. So it's the current row and the row before it. Okay? So here we have 1 is 1. This is 3 because it's 2 plus 1. This is 5 because it's 3 plus 2. This is 7 because it's 4 plus 3. This is 9 because it's 5 plus 4. This is 19 because it's 10 plus 9. It's basically adding the current row and the one before it. Okay. I can do one following, so I can take the current row and add the next row. So this is 3 because it's 1 plus 2. 5 because it's 2 plus 3. 7 because it's 3 plus 4, and down to 10, there's nothing after it, so it finishes. Okay. I can do 3 preceding. I can go 3 backward if I want. So now I'm going as far back as 3. So 1 is 1, 3 is 3 plus 2, 6 is 3 plus 4, 10 is 4 plus 3 plus 2 plus 1. 14 only goes back 4, so it's literally 5 plus 4 plus 3 plus 2, because we only go back 3, okay, all the way down. Any questions so far? Yes, sir. So question is, can you dynamically change that variable there? And I think the answer is you cannot, but there's a function later that allows you to do that. So in this case, you can't, but I'll show you a function in the next section which will allow you to put a variable in there. Okay? Other questions? Yeah.
I had some time to mess with the function. I couldn't get this set of range and rows. What's happening if we change this statement from rows to range? And
So if we change this query from rows to range, then what happens is that current row becomes the end of the partition instead of the current partition. And then I'm afraid, I've actually never tested it, but that's a great question. I'm going to have to, because I think the 3 preceding would still work, I think the 3 preceding would still work. It's just that the current row would be the end of the set. So it would give you the total from 3 before my row to the end. Instead of from 3 before to my current row, it would go all the way to the end. I think that's how it would behave. But that's a great, I will test that someday. That's a good question. Yeah. But this thing is just really weird. That whole changing of current row just appears to be a very complicated, process. In fact, what I tell people is just you should never use the defaults. If you're doing window functions, you should spell out exactly what you're doing. You should say range mode literally, rows mode literally, your beginning frame end, your beginning end, everything should be spelled out because the defaults are just so surprising to me. Other questions? Okay. We're gonna get up that hill. Eventually, it's gonna get very interesting. I know I could not figure out how to do this without taking you through all of the gory details, unfortunately. Now, here's the first time we're seeing an order by query in the window clause, okay? And by adding the order by query, we basically change the meaning of current row to mean my row and all its peers. So instead of showing 55, which is what we showed before, current row effectively means my row and all of its peers, meaning all of the rows that have the same X value as me. In this case, the rows are unique, so it doesn't matter, and we get effectively 1 all the way counting to 55. So in this case, literal current row similarly means current row. I'm sure there are a lot of queries that are using this type of syntax and don't realize if there's duplicates, it's going to add the duplicates as one set. And I'm sure some people have made mistakes, and that's why I'm always telling people never use the defaults. Always spell out the full syntax because it would be, for example, this is very clear. If I had 2 5s here, the number for the 2 5s would be exactly the same. And you'd be like, what? I asked for a sum. And they're like, yeah, but you're in range mode, so, right? So that's why I tell people not to use the defaults. Okay. Here's the same query with the defaults shown. And you can see we're in range mode, so effectively if I had duplicates, they would be treated as part of the current row, and again, unbounded proceeding to current row. Okay. I can do order by X range current row to current row, and again, I get my numbers 1 to 10. Each row is counted once. Okay. But the order by without duplicate values is kind of silly. So I'm going to create a new table called generate 1 to 5 x2, and it's going to contain duplicates for all the numbers from 1 to 5. And you're going to now visibly see how the duplicates are handled. Here's the default. As you may have guessed, the numbers 1 to 5 added twice is 30. So that's why we have 30 instead of 55. But again, very similar to the first query, window query that we saw. Here's a different example. We haven't seen anything like this before. Okay. Why are we seeing this? Well, it's order by X, range, unbounded proceeding to current row. You may remember, if you have an order by, then the current row is the last row that has the same order by value. Therefore, the first row sees 2 rows. It sees this row, and that's because they both have the same order by value. Okay? This row sees 4 rows because it has the same order by value. This one sees 6 rows, 8 rows, and 10 rows. Okay? So in this case, current row, which effectively is that, right? This is my default. It's saying beginning of the set, beginning of the partition to the current row, but the current row is not the current row. We're in range mode, so it's the last row in my that has an equal X value because I'm ordering by X. Okay. What's really interesting is if I change range to rows, that's range, that's rows, I get what I would expect. When I'm in rows mode, current row is literally the current row. So row 1 only sees row 1, row 2 only sees row 2, row 3 sees only row 3. And that's why you have these numbers that increasingly count instead of them jumping by 2s. Okay? And the sum is exactly what we'd expect as we add up. So just be aware that when you're writing a query, if you want current row to mean the literal current row, you're always going to specify range mode. Because if you don't, the query is going to work for a while until somebody hands you a report and says, why are these two numbers identical? And you're going to look at it, you're going to say, gee, I didn't see that when I ran the report myself. And you're like, I think I might know why, right? And it's because you used the defaults, you didn't say rows mode, and you got some really weird data there, right? So that's really, I think, a dangerous kind of a behavior. Particularly, I think a dangerous behavior to have it as a default. But because of the SQL standard and because of certain rules in relational algebra, they defaulted to range mode. I'm not necessarily going to get into that, but it's something that was very hard to understand. Here is another example. This is a little more illustrative. Order by X, range current row to current row, right? Range current row to current row. And as you can see, the first set, this set sees 2 rows, right? This set sees 2 rows. 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 And again, this is a 2 because it's 1 plus 1. This is a 4 because it's 2 plus 2. This is a 6, 3 plus 3, all the way down to 5 plus 5. Okay, so it's adding current row to current row, but it's effectively the beginning of the peer group, order by peer group, to the end of the order by peer group. Here's the same thing in rows mode. Makes perfect sense. Each row sees only itself. Current row to current row is literal current row to current row. And this column is duplicating that column, which is what you'd expect. A new feature, partition by. I haven't, actually, any questions? Let me see. Yes, sir.
Is it possible to use order by in a sentence and in the window order? What will be if we use order by in a sentence opposite order by in the window order?
Right. So the question is, can you use order by inside the window clause and also part of the select statement, in this case, the outer part of the main query? Yes, you can. The order by in the window clause really just controls the order that the window function is processed, and it doesn't have to be the same as the order of the output rows. So the window, an order by outside of a window function controls the order of display, okay, or the order of output. And the order by inside the window function represents the order of window processing. You could potentially have multiple window functions in the same query, all using different order bys, and then have the output come out in a 5th or 4th or 3rd order by. There's no restrictions on how many different order bys you can use in different window functions, and there's no requirement that it match the output order. Other questions? So the final area for this section is partition by. Partition by allows you to partition your data. In this case, I'm partitioning on X. So every unique X value is a partition. So this is a partition, these two rows are partitions, these two rows are partitions, these two rows and these two rows, and the output looks exactly as you would expect it, okay? But instead of using range current row with an order by, we just use partition. And you can mix them together. You can use partition and then order by and then a window frame, so it's kind of hierarchical. Here's an example that uses a partition of X greater than 2. What this means is that the red rows are part of one partition and the blue rows are part of another partition. Okay? So as you can see, this row set right here, because we're not using an order by, it's basically going to consume all of the rows. So this is 6 because it's 1 plus 1 plus 2 plus 2. And this is 24 because all of these numbers added together are 24. Okay? So again, partition with a partition without anything else, there's no order by, you're in range mode, you end up counting and summing all of the rows. If you add an order by, things become different. All of a sudden, we now see 2 rows in this set, 4 rows in this, and again, the count starts again at 0. Here's 2 rows, 4 rows, and 6 rows. So basically, when you have the partitioning, you're counting the groups as individual sets for window processing. Basically splits the sets up. Here's the full syntax with the default specified, X greater than 2, order by X, range between unbounded preceding and current row, and you have effectively that same display. If I change to rows mode, this is range mode. If I change to rows mode, you get what you'd expect. This row sees 1 row, this row sees 2, and 3 and 4, and then again down here it starts at 1 again and goes all the way to 6. Okay? And the totals are match up there. 1 plus 1 is 2, 1 plus 1 plus 2 is 4, and all of these together are 6, and the total again starts at 0 again, and the blue area runs it just the same in rows mode. Okay? Any questions? Okay, so that was a lot of the syntax. Now we're going to get into some of the more interesting cases, specifically the window-specific functions. So up until this point, I've used count and sum. These are generic aggregates. You can use them outside of window functions. The functions I'm going to be talking about in this section can only be used inside of window functions. Okay? Again, not like a sum or count, which can be used in and out. These can only be used inside of window functions. The first one is very trivial. It's called row number. One of the unusual cases where an underscore is used for a function in the SQL standard. Row underscore number effectively just gives me numbers for my rows. So basically, here's my rows, and here are the numbers for those rows. Okay. One aspect that you might be interested in here is that, oh, sorry about that, is that the row number function operates on partitions. And what that means is that the actual window frame that is used for that query has no effect on row number. All right, and let me back up a little bit. When you read the documentation, for example, the documentation here at the bottom, it'll say in the description of the function, it'll say numbers the rows in the partition. And you'll look at another function, it'll say gives you the numbers in the window frame. And you know, when I see the word window frame or partition, it kind of sounds like the same thing to me. Like window frame, partition, isn't that this? No, it's not. In the SQL standard, window frame is the rows or range unbounded preceding to current row, that specification. A partition is our partition clause or the entire set. So they're really different. Some functions are controlled by the window frame, and some functions have window frame has no effect on what they return. All right? And just when you're reading the standard, I have a slide at the end which kind of goes over this detail more, but just kind of keep that in your back of your head. Here's our first window-specific function. It's called lag, and what lag does is it gives us the row before the current row. All right? So just saying, for my current row, give me the row before it. Now, as you can imagine, the first row has nothing before it, so we return null. Okay? But the second row does have a row before it, so we return 1. Third row has a row before it, we return 1. Fourth row has a row before it, return 2, all the way down to 5. Okay? Pretty easy to understand how lag works. I can do lag 2, give me the row 2 before mine. In this case, the first 2 rows do not have a row 2 before them, but the other rows do. So it effectively shifts everything down. I can do lead. So this is a query that does a lag of 2, which means give me 2 before, and it also does a lead of 2, give me 2 after. So here I'm doing, I'm shifting everything 2, so this row sees here, this row sees this one, this row sees that one. And as you can imagine, the last 2 rows do not have anything past it, so they return null. You can also specify defaults. If you don't want null, you can make another value. Okay. Another 2 functions, first value and last value. Notice, for example, lag and lead work on partitions, right? Just like, so row number works on partitions, lag and lead work on partitions. First and last value work on frames, window frames. Ooh, what does that mean? Huh. Well, look at the first value. That one's pretty easy. It's like, okay, the first value is 1. That's pretty clear. But what about this? Why is it doing that? Why is it giving me not the last value in the partition? Well, that's because my window frame, I have an order by, so it's literally order by rows, range, order by range between unbounded preceding and current row, and therefore the current row is not the last row in the set, it's the current row of the peers. So it's the peer last current row. If I take this and I go into rows mode, that's what I wanted to see, right? Now I can see the 5 value, which is what I expected to see all along, okay? Which effectively is the last value now in the window frame, because I've opened the window frame up to be the full size of the partition. All right. Nth value. This is an option that gives you a specific row number, or like the nth row in the partition, in the frame. In fact, in the frame it says window frame right there. Okay. So what's really odd about this is that the first row can't see the third row because of the window frame definition. And we're in range mode, so it returns null. This one, the 7th value, I have to wait to get to the 7th row before I can actually see the 7th row because my window frame doesn't go out that far. If I specify, that's my defaults, right? Unbounded preceding to current row, my current row, I'm in range mode, it doesn't go out that far. Okay? But if I change my window frame to be unbounded following, then every row sees the 7th row. Okay? Kind of interesting. Any questions so far? Okay. So rank and dense rank, this is very useful. This is for ranking your results. So, for example, who crossed the finish line first, who has the lowest number, who has the second lowest number, and so forth. Okay. If I run this query with no defaults, with the defaults there, I get like nothing. It's all 1s. That's because there's no order by. If there's no order by, there's no ranking. No ranking, everyone's first. Okay. So if I specify a window frame, it doesn't help me. If I go into rows mode, it still doesn't help me. I need an order by. So I add an order by, and all of a sudden, yay, I get what looks like pretty good data. You might notice a difference between rank and dense rank. The reason is because of duplicates. So, for example, if two people cross the finish line at the same time, technically they're both first, right? I mean, it happens sometimes in competitions. They're both first, so they both get first prize. There's nothing you can do about that. What about the person behind them, the next person across the line? Is that person in second place or third place? It's really hard to say. So with the rank command, this second column here, it assumes that if two people are first, the next person is third, because there's two first places. With dense rank, we don't have a gap, and we assume the next person across the line is second. So again, depending on how you want to handle duplicates, you would use rank or dense rank for those. Another statistical command that's very popular is percent rank and cumulative distribution. These are attempting to estimate how what percentage of rows are equal or less than my row. So if I take a look at percent rank, it's saying what percent of rows are less than my row, and oddly, it excludes the current row from the computation, which I understand why it does this, but it's really odd. So for example, for these rows, what percent of rows are less than 1? Well, nothing, 0% or less. In this case, what percent of rows are less than 2, excluding the current row? So if you take the current row out, 2 of the 9 remaining rows are less. So 2/9 is 0.22. Same thing here, same thing all the way down, 89% are less than or equal 1/9, or 8/9 are less than or equal, because we exclude the current row. Cumulative distribution is a little simpler. It says what percent are less than or equal to my current row. That's pretty easy. 20% out of 10 are less than or equal to my current row, 40% less than or equal to my current row, 60% all the way down to 100. I'm not super happy with these calculations because, for example, if there's a lot of duplicates, I'd like the ability to know what percent are less than me, and also include half of the people that are equal to me. And I put a blog entry about it. Unfortunately, there is no existing statistical method that gives you that number. I think that would be a very useful number to give people. Maybe someday we'll implement it in Postgres. I don't know what we call it. But it feels like, for example, if I got a score on a certain test, telling me how many are less than me is useful, or how many are equal or less than me, but I'd like to kind of assume I'm in the middle of the group that has my score, and then tell me give me every less, and then half that are, that would be kind of nice, I think. Anyway, another function here on the right-hand side, percentile, n-tile. It attempts to break up the group into a specific number of groups, in this case 3. So I'm asking it to take the set and separate into 3 groups, a top third, a middle third, and a bottom third, kind of setting it up that way. And you can see this would be very useful for statistical analysis. If we go back to partition by, and I write partition by with my rank and dense rank, you can see that the ranking is done in the red partition with predictable results, and then the blue partition, brand new results, right? Completely new ranking because it's a separate partition. These window functions never move outside their current partition. They stay within their partition. Here's the same thing, rank, percentile rank, again in a partition. And again, the red has one partition calculation, the blue, a different partition calculation. Any questions? Okay. So here's where it gets interesting. What we're going to do is we're going to take all the stuff we learned and all the current row, range, mode, unbounded, blah, 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 and we're actually going to do some statistical analysis on some employees. And this is where it's all going to start to make sense, and I think it's all going to become useful. Just to summarize, none of the things that I'm showing you cannot be done at the client. You could download all this data and do all the processing at the client if you wanted to. But that's kind of awkward and very inefficient, so it's much easier to do the calculations on the server and just get the results for the client. So a lot of this is really a question of efficiency. The database can very efficiently perform these window functions and can do it in a way that's error-free. Sometimes doing these kind of calculations in your application can be quite complicated. So again, the goal here is to make it easy for people who want to do statistical analysis to do that analysis in the server instead of having to do it in the application. Okay? So let's set up our employee table called EMP, and we're going to insert 7 employees from different departments with different salaries. Here is the table, 7 employees, different departments, different salaries by ID. We can perform a sum and a count on this if we wish. This is not a window function. This is just straight generic aggregates. So I have 7 employees. I have a sum of all of my salary, and I have an average for that salary. Not super useful, but this is just a standard aggregate. I could do a group by. Again, this is not a window function, but I can do a group by. I can say how many people are in each department, what are my departments, how much people in each, what is the total salary in each department, and what is the average salary in each department. Again, we're not using window functions, so it's taken the 7 rows and it's shrunk it down to 3. Okay? Remember, in window functions, we always keep the same number of rows, so this is not a window function. We could do roll-up. I'm not sure how many of you are familiar with roll-up. This was a feature added, I think, in 2 releases ago in Postgres. And what it allows you to do is to do something like a group by. In this says group by department. You get a nice total of your departments, and then you get an additional row called a roll-up row, which basically takes all of the rows in the set and gives you kind of a nice cumulative total. Okay? Very efficient, much easier to do this way than in the application. Still not a window function, but it's kind of a neat way of doing analytics. I just thought I'd show everybody. So back to our 7 employees. We're going to order them by salary. Okay? And here's our first window function using these employees. So we have select name, we have salary, and then we have a sum of the salary, but instead of just saying sum, we have an over keyword, and we use the famous open parenthesis, close parenthesis, which of course is going to use the defaults. And as we've seen, the default for sum is to sum all the rows. So we have the sum of all the employees on every single row. Remember we had the example before, we just had 55, right? This is just the same idea. So instead of being 55, it's 40,200, okay? The same behavior, yes?
Does window function works faster than subquery or not?
So does a window function work faster than a subquery? The way window functions work is that they basically process they process the result, and then a separate stage computes the window function on the result. So it's kind of a separate stage that happens after the query. So the query kind of runs without the window function, and then we compute the window function values as a secondary stage of that. A subquery is really kind of the opposite. In a subquery, you're going to execute the query first in the from clause, and then you're going to run a query outside of it. You can do similar things with common table expressions or subqueries. Maybe you're saying, normally the window function is more efficient because When you do something in a subquery, normally you're having to recompute that subquery over and over again, or you're having to get the subquery for every row, you're having to recompute some number. And that's fairly efficient. The window functions are designed to basically understand that it can compute the result and then apply it in one pass, instead of when you have it in a subquery, potentially you're recomputing that value multiple times. Other questions? Okay. So again, this is now you might think, okay, this is not very useful, right? Like, why would I want to see the total salary on every row, right? And the answer is there actually is a use case for this. What this query does is it gives you in that last column the percent of total salary for each employee. It's kind of neat, right? Very nice to do it in the database. What you basically have is you have your name, you have your salary, and then inside in red here, we take the current row salary and we divide it by the sum of all the salaries. Okay, we multiply it by 100, we round it by 2, and look, looks really nice. So there's a great example of where having the sum of all the employees on every single row actually is really useful. I have a lot more complicated examples, but that's a really nice, clean one. Here's the next one. We can now compute cumulative totals. So I don't know why you might want to do this, but effectively we have the first employee and his salary. We have the next employee, which is the sum of their salary and the person before them, all the way down. This is probably not very useful. However, if you were doing something like cumulative snow for the month, or cumulative rain for the month, or cumulative accidents for the month, this can be useful. It's not very useful for salary, but for time series data, sometimes it's useful to be able to do a cumulative total like this, and unbounded proceeding to current row in rows mode is very useful. Okay, it's not useful in range mode, because if you did it in range mode, and I actually made this mistake once, if you did it in range mode, Andy and Sandy would have the same sum. I'll say that again. If I had I'm running this in rows mode, but if I ran it in range mode, Andy and Sandy would have the same sum because it would have computed from the beginning of the set, and Andy would have also included Sandy because they both have the same salary, the same order by value. Okay, so there's a little caution there of why that range mode can be so dangerous. Here's another example. I'm computing the average. So I have a third column, and I'm just computing the average of all the employees. You might think, oh, that's not very useful. Why would I want to do that? But I can actually do this. And what this does is to effectively, for the last column, well, we kept the average right here, okay? But for the last column, we subtracted their salary from the average, and we got a difference. So I can now see how much more or less each employee is paid than the average. Those in red are paid more than the average. Those in blue, less than the average. Kind of nice. Kind of hard to do in the client. It's very awkward to do this, but very convenient to do it in a window function. Okay. Questions? Okay. This is another kind of comparison. Instead of comparing the employee to the average, I will compare the employee to the next lower paid employee. Okay? So I'll compare that employee to the next lower paid employee. And what that tells me is that Mike is making $500 more than James. James is making $300 more than Betty. Betty is making $900 more than Sandy. Okay? Now, Sandy and Andy have the same salary, so Sandy is being paid no more than Andy, okay? Andy's 600 more than Tracy, Tracy 200 more than Carol. Carol, unfortunately, is the lowest paid employee, and there's no one paid less than her, so she would have a null. Okay? Kind of interesting. Here's an even bigger one. Okay? This is an interesting statistical analysis. What it is showing us is in the first two columns are the same. Third column, how much more is this employee paid than the lowest paid employee? Okay? And then in this last column, what percentage more is this employee paid than the lowest paid employee? Okay? So you're getting an analysis to sort of look how much total difference and what percent difference is there from that lowest paid employee. The way we did that is for this column, we took salary and we subtracted it by last value. And for this final percent column, we took the salary, subtracted from last value, and we divided it by the last value, which is the lowest paid employee. Okay? To make this work, however, I had to set up a special window clause, unbounded preceding to unbounded following. So I set up this window clause, I called it W, and I used that window clause in 1, 2, 3 places in my query to shorten how much I had to type. It's kind of interesting. Yes? So you're saying, can I use a window function instead of, I'm sorry? Minimum function. Okay. So the question is, how is this different than using a minimum function? You could have used a minimum function for some of this. What you would have had to do is to create a common table expression using with, okay? And you would have had to put the minimum computation in the common table expression. And then in the outer query, you could have referenced the common table expression. Or you could have put the minimum computation in a subquery inside the from clause, which is, I think, what you were suggesting, and then reference that minimum in your clause as you went around. So you could have done that. The problem is you're still going to need to use window functions to compute the differences. Like, well, no, I guess I take that back. You could have, if you did the minimum in a common table expression or in the from clause, then you wouldn't have had to use window functions because every reference here to last value would have been a reference to that minimum. So yes, that's a good point. Yes, you could have done it with a minimum. The reason we do it this way is because if you place the minimum function separately, we're guaranteeing that we have to process the minimum function independently of the rest of the query, right? So we're almost, by definition, having to go through the data twice. Unless we have an index on the salary field, which we probably don't, okay? We're going to have to basically sequential scan to get the minimum, make that a value in the from clause or in the common table expression. Then I got to go back to the table again, sequential scan it again, probably, and compute this number. By doing it with a window function, we're basically computing the result first, then ordering the result. Then I can pick the minimum real fast because it's only a couple rows, it's right there, right? So in terms of efficiency, it's much easier to do it this way than separately create the window function. That's why people wanted this feature. They could do it, you could have done a lot of these things without window functions, but the efficiency is a problem. Other questions? Okay. So again, that's a great one. Here's another example of rank. Remember we ranked salaries here. So we now have number 1 salary, number 2 salary all the way down. And in fact, this is a great example. We can see the difference between rank and dense rank with our salaries. So if Andy and Sandy are both 4th in salary, is the next person 6th, or is the next person 5th, right? And that's kind of your question of how you want to use those rankings. Okay? Interesting. Going a little more sophisticated, we can use partitions. In this case, I am using a partition by department. So what I am going to compute here is the average of my department salary. And for each individual, I am going to see the difference between their salary and the average. Okay? So for example, for the marketing department, this is the average salary. Mike is making 400 more than the average, and Betty 400 less than the average. All right? Just to go back to the question about minimum, this would be very hard to compute with a minimum function, right? When we only had one, in this case, when we only had one minimum salary, that was easy. But in this case, we now have averages for every single department. So you'd have to like run a query and compute a set of minimums or averages for every department, and then you'd have to join that to your table, and then, you know what I'm saying? It gets to be really, things get to be very slow when you start doing that, right? Because you're taking the data, you're shrinking it down, and then you're joining it back to its own data effectively. Whereas with a window function, it's much more efficient. So here, partition by department, I can now see the difference between the average salary and the person's salary, which is kind of nice. This is a little cleaner. Notice I specified department here twice. Okay? So I can take that out, and I can put that in a window function. So there's my window function called D right here. Okay? And the clause is partition by department, and now I can say over D, and I don't have to repeat myself as much. It's kind of nice. Here's a little more sophisticated example. Instead of comparing the employee to the average for the department, I compare the employee to the next lower salary in that department, within departments, okay? So Mike is making 800 more than Betty. Betty, there's nobody else in the department, so there's no one less, right? Sandy is making 800 more than Carol. There's nobody less. James more than 1,200 more than Andy, which is, wow, impressive. And then Andy is 600 more than Tracy, and Tracy, there's nobody less than Tracy. So you kind of get the idea of this is now comparing not to the average for the department, but comparing it to the next lower salary in the department. This is another example. I'm comparing the ranking of salaries in the department compared to the ranking of salaries within the entire company. So here, Mike is the highest paid employee in his department, Betty second, and so forth. 1, 2, 3. These are the rankings within their departments. These are the rankings within the entire company. Okay? It's kind of interesting. So department rank and global rank, we'll call it. Okay? Any questions? Okay. So let's just wrap up here. We can take some more questions. If you're writing window functions, and I think you've seen some of the value of window functions at this point, the first couple questions you need to ask, do you need your result set split? Do you need to split the results? If you do, that you would use partition by. We used this, for example, when we did, we partitioned by department because we need to split our data by department. Do you want any ordering in the partition? Well, if you do, then you'll use an order by. How do you want to handle rows with the same order by value? Well, do you want to use range mode or rows mode? You should decide that explicitly. Do you want rank or dense rank, handling duplicates? Do you need to define a window frame so you're not duplicating your frame a lot? You can have window functions are independent, so you can have a window function that defines its own partitioning, its own ordering, and its own window frames independent of other window functions in the same query. You can define multiple window function names, window names if you want. But also pay attention to whether a window function operate on frames or partitions. Specifically this slide right here. The upper set of window functions, these all operate on frames. Remember, unbounded proceeding to current row, range mode, rows mode, these all affect these functions. That is the generic aggregates, sum, average, count, for example. First value, last value, and nth value all operate on frames. All of the other functions operate on partitions. It doesn't matter what window frame you define. So lead, lag, row number are all row access type of functions, and ranking functions also operate on on partitions, not on window frames. Okay? Window functions never process rows outside their partitions, but without a partition by, their entire set is a single partition. So, again, we were trying to show you how window functions are used for analytics. As you can see, it is helpful to be able to do some of this analytics in the database. It's more efficient. It causes fewer errors, and it causes you to use less. It's faster to do your analytics in the database and then just return the result to the client that you need, greatly simplifying your job as application developers. So I'd like to take any questions pretty much on any topic related to Postgres, and then we can conclude. Does anyone have a question? Yes?
How to use several windows in one expression?
So the question is how to use separate window functions in one expression. I'm going to back up to an example here. No, hold on, sorry. Here's an example where I am using effectively two window functions right here, last value and thing. Maybe a clear example is this one. So this average salary over partition by is one window function, okay? And this is a separate window function. Average over partition by department is another window function. So you can specify as many window functions in a query you want. And in this case, they have the same clauses, but you could use different clauses as well. They don't have to match. Other questions? Yeah.
Every time application developers ask how to debug or how to test this very, 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 very big query, how to analyze, how to find the mistakes with.
So the question is, if you have a very complex query, how would you debug it? How would you figure out what was wrong with it? It's hard to say. I mean, if you want to look internally at what it's doing, of course, the explain command, if you take explain and the query, you'll see internally what index it's using, what type of join method it's using, and so forth. But in terms of finding mistakes, normally what I will tell people to do is take the query and run it in pieces. Because normally if a query is not running, there's some part of it that isn't working. And you often have to decouple the query and run the pieces and figure out which piece isn't giving you the right number, right answer. And then you can put it back together again. But I don't know of an easy answer, unfortunately, for debugging, except to take a complex query, break it into pieces, and run them and look at the result. I've had to do that many times myself. Yes.
Is available user-defined window functions?
So, is it possible to create user-defined window functions? Indeed, it is. Postgres has the ability to create user-defined functions, user-defined aggregates, and user-defined window functions. I know there's a whole bunch of user-defined aggregates. I don't know of any user-defined window functions that are popular, but there is certainly an API that allows you to plug your own window functions into Postgres. I believe the window functions have to be, originally the window functions could only be written in C. I think there's a way of writing the window functions maybe in Python. Oh. JavaScript, thank you. So window functions can be written also in JavaScript, PLv8. But normally the window functions are written in C for efficiency and so forth. But there is work to allow for more complex, easier to create window functions. Good question. Yes? Can you use a window function in a window function? No.
For function. For example, function can generate some number. Can we sum this function or?
Oh yeah. So you can. So could you call a function in a window function? Right. So yes, and the reason you can is because this is literally a function, but it would have to be, yeah, you can, yeah, because these are just really functions. Now, the problem is, so you can call a normal function in a window function. However, a normal function doesn't have the ability to reach rows that are earlier or later than your current row. Okay? So when you create a custom window function, for example, you have to use the API that allows it to access a different row. If you wanted to use a regular function that didn't need to access another row, you could use it, but it's not going to do anything because it's a function, right? It's not, normal functions take a value or a row and process it. They normally can't reach forward or backward in the set. And that's why normally if you're using a window normally if you're creating a window function, it's going to have to use a special API. So you couldn't say, you could say factorial, like let's say factorial, you could say factorial, but you couldn't say factorial of the previous row. You could say factorial of lag previous row. So you could use the window function to get the row before the value before, and then call factorial on it, right? Anything, here I'm subtracting. So subtraction or a function call is identical. But I'm question whether you'd want a normal factorial without any reference to a window function, because it only really can't reach on other rows. It wouldn't be that useful. Yes?
Are there some plans of creating an HTTP available interface for PostgreSQL?
I'm sorry, an HTML? HTTP, okay. So the question is, can we create an HTTP interface to Postgres? There are some projects that have done that. It's typically I don't know the term, but a REST, R-E-S-T interface, which effectively allows you to write queries using a URL style syntax, and you send that URL to, in this case, to a broker, and the broker will send the query to Postgres, return the result back. And so that we have seen a number of people. I'm trying to remember, there have been a couple of very popular ones. I don't remember the one. There were maybe 6 years ago, somebody had one. It was being used by a medical company that wanted to give their application developers just a URL interface to the database. And they had very simple syntax of how to write a query. And it was actually pretty popular. He presented this HTTP broker application at several Postgres conferences. And I thought it was very nice. Unfortunately, I don't remember the name of it, but if you look around, there is HTTP interfaces. Whether Postgres should natively do that, I don't know yet. Nobody's really asked us for that yet, for sort of an HTTP native interface to Postgres, because the SQL language is so complicated that you'd want full access to the SQL language with permission checking and everything, and transaction control, and the REST interface isn't really good for that except for very simple use cases. And that's why it's usually a broker is used. Yes?
Are you going to add support of time series data working with more performance in insert-only mode?
So the question is there work on doing more time series capabilities to Postgres? Postgres does have a range data type, which allows you to specify both a start and stop time for a specific column. So the column, instead of, for example, holding a timestamp, holds a beginning timestamp and an ending timestamp inside the same column. That range column can be indexed, so using GIST indexing, developed here in Russia. You can very efficiently pull out records that contain certain time spans. You can say, give me all of the rows that happened in this day, for example, or this week. You can overlap them. You can do all sorts of very complicated processing with range data types, which is similar to a time series. There also is discussion of implementing the SQL standard for time series. It's a little different. It's called bitemporal, and it's called bitemporal because it uses the range data type, but it has two ranges. It has a range data type for the active date of the row, and it has a range data type for the entered date of the row. And I know that sounds really weird, but there is continuing SQL standard evolution on handling time series data in a better way. But Postgres already has the range data type, which is very powerful for doing time intervals, and has very good indexing support for that. So for example, a rental car company could say, here's when the car was rented and here's where the car was returned, that kind of time of start and stop, or room rental. If you look at the range data types, I think you'll be impressed at how much it can do.
But I'm most interested in improved performance by using the data which you can only insert into tables, update, not to support concurrency model or something.
Okay, are you thinking more, okay, so the gentleman said that he's thinking more of data that can only be insert and doesn't get removed. So you're thinking more of being able to query back in time to see what the records were at some time in the past. So we call that time travel. It's also called flashback, but different vendors have different names for it. When we originally started with Postgres in 1996, we had that feature. That feature came from the university. However, probably in the next couple years, we removed that feature because obviously if you don't remove the rows, the database gets very big. So we actually implemented a way of cleaning up the old rows. It would be fairly trivial for us to allow you to turn off the cleanup. And we are in the process of discussing if we should allow this kind of case, so you could just turn the cleanup off. And the way Postgres works, it's a non-overwriting storage. Every update is a new row. So it would be fairly trivial to implement this. So I think in the next couple of years, we'll definitely have that capability. It's not hard to do. It's almost turning something off is all we have to do, because we already have the code to do the cleanup. We just turn off the cleanup code and we allow you to look back in time and it'll be done. Some people do it now. There's an external module, I think it's in the contrib, called time travel, which does it manually. It just adds a column in your table, which is the creation time, and then you just turn on a cleanup and all the rows stay there. But yeah, we can do that definitely. Other questions? Yes. So are you asking how a window function work if you had a window function in the where clause? Yeah. Yeah, how would you do that? Right. I think the way it works is that it processes, so I think the way, I haven't tested it, but I think the way it works is it processes the entire query, without the window function part. And then once it gets the result, it removes the rows that don't satisfy that where clause. So basically the where clause restriction is deferred to a later time, and then we process it later. But I've never tested it. Nobody's ever asked me that. But yeah, you probably, the assumption is that Postgres processes the from clause first, then the where clause, then it returns the rows. Effectively, you don't have to do it that way. You can kind of delay the where clause for later. So for example, if you use the having clause in SQL, the having clause operates after the group by clause, right? So it's a similar kind of case. You may have to actually put, now that I think of it, I'm wondering if you have to put the window clause in the having clause. Because the having clause is expecting aggregates, and I bet you could put the window clause in the having clause, and therefore it would process after your where clause. I think that's how you do it. We might get sloppy. We may allow you to put the aggregate in the where clause, because I think we even allow that now. We don't require the having clause, because I think we're smart enough to pull it in the having clause if you have it in the wrong place. But I haven't tested it recently, so I'll have to check that out. Good question. Oh, I'm sorry. Somebody had their hand up? No. Oh, yes, I'm sorry.
Does logical integration handle here? For example, if we subscribe one table to another, and then we alter the first table, the source table, what happens?
Yeah, so the question is if you set up the subscriber, publisher, subscriber logical replication, and somebody alters the table on the primary, what happens on the standby? And the answer is bad things happen because currently the DDL is not replicated. This is related to the gentleman who asked about upgrades using logical replication. The problem currently is that to replicate an entire cluster using logical replication, you have to replicate every table, and every DDL has to be identical and so forth. So if you're doing that kind of thing, you are going to need to make sure that you do the DDL at the same time on both. Although now that I think of it, I'm worried that you wouldn't be able to synchronize it. Like if you drop the column, like it would still be there, and like how would you do it synchronized? I'm not sure. Maybe you have to pause replication and then run. That's what I think you have to do. Yeah, there's a pause command to pause replication. Then you have to run the DDL on both machines and then unpause replication to. It's a new feature. We haven't really gotten to. I haven't seen many questions about this, but I would say right now it's fairly fragile and it needs more work. It needs DDL replication. it needs multi-master at some point. So I think we still have some work to go, although I haven't seen much. Postgres 11 doesn't look like it has much improvement in logical replication. So I think we still have work to do there. Yeah. True. Other questions? Okay, well, good. Thank you so much. It's been a pleasure being here, and I'll be down if you have any questions. Yvonne, do you have anything closing to say? He might have a long-winded speech to give us here. He's coming down. He is our host, and he will have wonderful words to say, I'm sure.
Ну, я тут немножко дополню. Значит, вот сейчас говорили про темпоральные базы или про time travel, про это. Значит, если интересно кому почитать, есть такая женщина, Генриетта Домбровская ее зовут. Вот можно погуглить, у нее есть хороший доклад и статья про темпоральные базы. Темпоральная и битемпоральная база. Вот, это раз. Соответственно, можно гуглить слово темпоральное и битемпоральное, очень интересно. Имя? Генриетта Домбровская. Генриетта Домбровская. Она одна такая во всем мире. Вот. Еще про логическую репликацию. На самом деле, мультимастер – это действительно огромная проблема, но в нашей компании она решена. Вот. Поскольку существует коммерческий мультимастер на базе Postgres, где как раз вот те проблемы, о которых говорит Брюс, решены. Он сделан на базе логической репликации и на базе некоторого еще менеджер распределенных транзакций, Distributed Transaction Manager. Вот. Там и DDL реплицируется, и транзакция в масштабах кластера есть. Вот. Но это пока штука только за деньги. Но со временем она пойдет в open source тоже. Вот. Ну, спасибо за внимание. Следите за анонсами, будет в ноябре, PGConf, я надеюсь, здесь все получится. Я поговорил с руководством университета, здесь тоже поддерживают. Так что... Еще раз спасибо, все, закончено, можно расходиться. Еще есть несколько книжечек, есть. Что, мне их везти в Новосибирск? И наклейки есть. Конечно, конечно. Наклейки, вот магнитик еще один остался. О, лучшие вопросы, Брюс, лучшие вопросы. Может, еще maybe two more best questions.
Let's do this gentleman right here, because he asked me a question. Oh, and that woman, the woman who asked me the question during the break first. The woman who asked me the question about the...
Девушка,